Okay, so for tonight, we're covering two of our big rules for triangles. So the first set of problems that we're going to deal with on our triangles tonight is that triangles have to make or add up to, all three angles have to add up to 180 degrees. All right, so if we're presented a triangle setup such as this, a little different than what we're used to. We're not used to seeing this x plus 20 thing here to represent an angle. But that's where we're at now with our algebra and stuff we've been doing in chapter 6. So things are going to look a little different for you. But again, same kind of idea. All three of these angles added together have to equal 180. So if we write that out, x plus 54 plus x plus 20, we know that that has to all total 180. And once we get it written out, this should look very familiar to you as everything we've been doing in chapter 6. All right, 54 plus 20 are like terms. X and x are like terms. And now we can just fall back on what we've been doing in chapter 6. Subtract your 74s. Divide everything by 2. X equals 53 degrees. Now here's the catch. The original question wants you to know these two angles. So again, x equals 53 tells you what this angle is. We still haven't figured out what this angle is, but it's a simple one more step. It says 50, our number plus 20. So now we know that this missing angle is 73 degrees. All right. So again, you should be doing 3 of those this evening. The other thing, I guess, I didn't throw it on here, is we can do the same thing with the perimeter of a triangle. All right. And if we have an obtuse triangle here, okay, I'm just making one up here off the cuff. This side may be x, this side may be x plus 8, this side may be x plus 12. And all we've been told is that our perimeter is equal to 40. Don't know for sure if that number is going to work out too well for us. Why don't we make this a 49? No, I don't know what I want to hear. I'm trying to make this one up for you. Let's make it 47. Okay. So again, how do we calculate our perimeter? We find our perimeter by adding all 3 sides together. Again, we're not used to this notation. We're used to just seeing numbers here. But you guys have got some algebra background now, so things are going to start to change. But again, same concept. Add all 3 together. So x plus 12 plus x plus 8 plus the third one. We add all 3 of them together, we know, now that Mr. Wolf settled on a number, needs to be 47. Again, same concept now. We should recognize this as just an algebra equation. Like terms, we got 3 x's. 12 plus 8 is 20, and it has to equal 47. Subtract 20 from both sides. Divide everything by 3. X equals 9. Again, this is just a value. The original question is how long is each side? Well, this one's 9. This one is 9 plus 8, so this one is a 17. And this one is a 9 plus 12, so this one is 21. So that would be all 3 measurements. Okay? All right, and then, of course, at the end, we have some Pythagorean practice. All right, Pythagorean theorem. We got some right angles, right triangles. We want to calculate the missing sides. So remember our formula, a squared plus b squared equals c squared. All right, a and b are your legs. Legs are the sides that make the right angles. So these would be our 2 sides. 12 squared plus 12 squared, so we got 144 plus 144. So 288 equals c squared. Whoop, excuse me. I should have substituted. This should have been an h, different variable. All right. Now our diagram only wants h, and we have h squared, so we got to get rid of that squared. How do you get rid of that? Square root it. So we need to get the square root of 288. Yes, I'm cheating. I do not know what the square root of 288 is. So the square root of 288 is approximately, boy, pretty close. Approximately 17, 16.9. So we'll round that to 17. Okay? So you should be doing about 3 of each of those tonight. And as always, bring any questions to class tomorrow. We'll spend some time on it. Have a good night.